Hello everyone, my name is Khalid Hussain and I am from Pakistan. I hold an MS degree in mathematics and I have been teaching over 8 years including O-level and A-level mathematics. Currently I am teaching at JC University Hyderabad where I handle subjects like calculus, linear algebra, statistics, mechanics and differential equation. I try to explain difficult concepts in a simple way so students can understand it better and I enjoy using technology in my teaching to make learning more effective. In today's video, I'll show you how to solve simultaneous equations using matrix method. This is a useful technique in algebra and helps us to solve equations more easily, especially when we have multiple variables. So let's get started. What are simultaneous equations? A system of equations with multiple variables that need to be solved together is called simultaneous equations. For example, let's consider a system of equation like 3x minus 4y is equal to minus 5 and we have another equation minus 2x plus 5y is equal to 8. So this is the system of equation. If you observe that we have two equations and each equation involving two variables like x and y in first equation, also x and y in second equation. So this type of system, we can say that this type of system of equation like uh, simultaneous equations of a system. So in how many ways we can solve this system? We can solve by using substitution method, by using elimination method, and but in this video we are going to solve this system using matrix method. For this, what we have to do, the first step is, we can write it step 1. What we have to do, we have to make matrix equation. First we have to make matrix equation like ax is equal to b. And what will be the a here? A will be the coefficient matrix. We can say coefficient matrix, and in this matrix we will consider the coefficients of these two equations, like 3 is the coefficient of x and minus 4 is the coefficient of y in first equation and minus 2 is the coefficient of x in second equation. So 5 is the coefficient of y in second equation. So these coefficients will make an coefficient matrix. So we will write these coefficients in a square matrix in A, and in X we will consider variable matrix and it must be column matrix. So variable matrix X will be the variable matrix, and B, finally B with constants matrix of constants. So here minus 5 and 8 are constants, so we will make a B matrix using these constants. Now observe that how can we solve this type of equation. For example, if we have an equation ax is equal to b, how can we solve this? For solving this, to find the value of x here, we have to remove a from the left side. So a is a matrix, a is a square matrix, it will be the square matrix. To solve this equation, we have to multiply a inverse on both sides, then to the left hand side and also to the right hand side. If we multiply a inverse to both sides, we know that a inverse a becomes identity matrix. So when we use identity in this equation, it will become I x is equal to a inverse times b. So we know that if we multiply a matrix to identity matrix, it becomes the same matrix. So we will have x is equal to a inverse times b. So we can find the solution of this equation in these following these methods. So what we have to do in step 2 is we have to find the inverse of a. Is in step 2 we have to find a inverse. And how can we calculate the inverse of this A matrix is we can calculate in two steps. Number one is we have to calculate determinant of A, or we can say determinant of A. And second step, we have to find adjoint of A matrix. So how we calculate the determinant of A matrix? We have A here. We have to make the matrix equation. Now we have to convert this system of equation in matrix equation. Then we will find the inverse of the matrix and so on. So A becomes the in first equation the coefficient of x is 3 and the coefficient of y is -4, so we can write 3 -4, and for second row we will use the coefficient from the second equation, -2 and 5. Here we will write -2 and 5, so this will be the A matrix, and now we have to make a variable matrix, and it must be the column matrix. So in our system of equations we have two variables like x and y, and it will be equal to the constant matrix, and it will also be the column matrix. So in this our system of equations we have -5 and 8 as a constant, so we can use in this matrix -5 and 8. So this is our finally matrix equation. This is square matrix represents A, and this is column matrix, variable matrix is X, and this is B. Now what we have to do in step 3 is, now we have to find determinant of this A matrix. We can see determinant of A, and observe that this is the 2 by 2 matrix, and we can find the determinant of this matrix by multiplying the diagonal elements, and of diagonal elements we have to find the difference of diagonal elements and the off diagonal elements. So here we have 3 multiplied by 5 minus, and of diagonal elements we have -2, -4, so we can write it here -4 multiplied by -2, so it will become 3 5 is 15 minus -4 multiply -2 becomes 8, and here we have 7, so we can write it as determinant of A is equal to 7. So for adjoint of A, observe that we have just 2 by 2 matrix, so we can find its adjoint easily. Just what we have to do, we have to replace these elements, diagonal elements, and this is the A11 position, and this is the for example A22 position. So we have to replace these two elements, and we have to change the sign of these two elements. So adjoint of A becomes 5 4 2 and 3. Now what will be the A inverse? After following these two steps, we have calculated determinant of A matrix and adjoint of A matrix. So A inverse will become 1 over determinant of A times adjoint of A. So we have to find A inverse, then we will multiply this matrix to the B matrix, and we calculate the values of variables. Finally here A inverse will become, we have determinant 7, so 1 over 7, and adjoint matrix is 5 4 2 and 3. So now what we have to do in step 4 is we have to find the values of unknowns. In step 4, what we have to do, we have to multiply x is equal to A inverse times B. So we have our x matrix like x and y, and we just calculated the inverse of A inverse. So we will use this result here. This variable matrix will be equal to 1 over 7 times adjoint of the matrix A is 5, 4, 2 and 3. And we have our constant matrix is minus 5 and 8. So what we have to do in this final step, we have to multiply these two matrices, and it will become, we can write 1 over 7 as it is for time being, and we have to multiply these two matrices. For example, 5 first row, how we can perform matrix multiplication in this, uh, we have to multiply the first row with this column, and here is 5, 5 times minus 5, it will become minus 25, and 4 times 8, it will become 32. And we have to multiply the second row with this column, so 2 multiplied by minus 5, it will become minus 10, plus 3 times 8 becomes 24. So we can write it as, xy is equal to 1 over 7 minus 25 plus 32, it will become 7, and minus 10 plus 24, it will become 14. So now we have to multiply. This is the scalar multiplication with the matrix. So we have to multiply 1 over 7 to 7, it will become 1, and 1 over 7, when we multiply 1 over 7 to 14, it will become 2. So the final result will be xy is equal to 1, 2. It means x is equal to 1 and y is equal to 2. So this is the required equation. By using matrix method, we have calculated the value of x and y. So this is the required solution.